Boom. Okay, so sorry, this shouldn't be recorded. So yesterday we talked about a couple things. These will be on Thursday's quiz. Okay, now don't panic too much. You know, a quiz, yeah, it's important, but it's not that important. Okay, you could fail 2 or 3 quizzes and still get an A in this class. So don't panic too much. Okay, the first thing we want that we talked about yesterday is if I gave you a formula like that, A equals P plus PRT. This is a formula about interest and percent and all that kind of crud. You don't have to know it, but I want to solve for T. That means get T alone in that problem. The other thing I want to do, we'll kind of do it here. I'm going to do a couple, but I want you to solve this. Okay, 7 minus 4x is less than or equal to 2x plus 49. This one I want you to solve. I want you to graph the answer, and I want you to put it in interval notation. So put your final answer in interval notation, graph that answer, and then solve this. Obviously, you're going to solve it first. So I'll stop recording now and give you guys a few minutes. Okay, so let's go for this one. It's a formula. We want to solve for T. That is, we want to get this T right here by itself. This is how I see it. And I'm just going to do it. And then I'm going to hope that somebody asks me questions and says, well, how did you know to do that step or whatever? Or actually, I really hope that everybody understands it, but that's not going to be happening. So the first thing I would do is I would take P away from both sides. This P, okay, the first one. So that's going to give me A minus P, because I know I can't subtract them, so I just show mathematically I tried, equals PRT. Now, the next thing is I notice that PRT actually means P times R times T. And we did a problem right at the tail end of class last night with circumference. If you go look at your notes on that, where we just divided everybody. So I want to get the T alone. So I want to divide by PR. Divide this whole side by, by PR. Okay. I know because those are P times R times T, but I'm dividing by P times R. So I know that all of those P's and R's are going to cancel each other out. Okay. And I'm just going to get T all by its own sum. Yay. Okay. This I can't do much with, so I'm just going to leave it as A minus P over P R. And that would be good enough. You've satisfied the problem. You got T alone. Okay. If you wanted to go further, last night we talked about separating this A over PR minus P over PR. That is legit. You can always take a fraction apart. If you had A plus 7 over 9, you could take it apart as A over 9 plus 7 over 9. That looks like A over A. You can always take a fraction apart like that. Single denominator goes with both of those in the numerator. But this is wrong, because if you separate it, while separating isn't wrong, leaving it in this form is wrong, because these P's cancel. So they cross cancel, and remember, technically they leave a 1 up there. So you could have A over PR minus 1 over R equals T. That would also be acceptable. Okay, so this is the one I would go for because it's the least amount of work. Okay, but if you wanted to separate it, you could, but you do have to reduce those, cancel those out. Okay, and then you get that answer. So anyway, that's my answer for the first problem. Any questions? Sure. Okay, cool. So moving on to this one over here. Okay. General rule of thumb, if it was an equation, if this had been, I'm going to erase this, I'll put it back in. If this had been an equal sign, then we don't care what side the X is on. All we ever said was get the X on one side and the ordinary numbers on the other side of the equal sign. That's all we ever said. But it is generally safer, okay, generally, not required, that if it's an inequality, the less than greater than problem, it's safer to have all your X's on the left-hand side. Okay, not required, but safer. Okay, so to do that, I would take 2X away from both sides. That would give me 7 minus 6X is less than or equal to 49. I would subtract 7 from both sides because we want to get X alone. Okay, so now watch, I'm going to make a mistake here. Okay, a really, really common mistake. You see what I just did? What mistake I did?
Multiply.
No?
Negative 6.
Yeah.
Got rid of the negative.
The 6 is negative or minus. Minus and negative are almost the same thing. Okay. So a lot of students, they took away 7 from both sides. That's legit. Okay. But when they bring this down, students forget to bring down the minus. That 6 was a minus in that step. It's still a minus down here. Okay, as it comes down. Now we're going to divide both sides by -6 because we want to get the X alone. Divide by -6. So this gives us X. This gives us -7. 42 divided by -6 is -7. But the rule was when you multiply or divide both sides by a negative number, you have to flip the inequality over. That was that big thing, you know, math is real big on truth, justice in the American way, and all that Superman stuff. But basically, that's what it comes down to. To maintain the truthness of a statement, you have to flip the inequality. If you divide both sides by negative or multiply both sides by negative. Okay, so we get this. Well, we're done. That's okay, except the instructions said, I want you to graph it and I want you to put it in interval notation. So to graph this, it would have, here's 0, here's 7. Okay. One of the advantages of always having X on the left-hand side, okay, if you train yourself to do that for an inequality thing, X on the left-hand side, is the symbol here points in the direction you're going to shade. Okay, the symbol, the greater than symbol, is pointing in the direction. So we're going to shade this way. And it's a negative, oh, I'm screwed up. Beg your pardon, I really blew it big time. -7, dope. 0, -7. Okay. It's solid circle on the -7. Okay. And it's still pointing in that direction. Sorry, choked. And lastly, so there's the answer, but there's the graph of the answer. But the instructions also said give it to me in interval notation. So that would be bracket, -7, comma, infinity, parenthesis. It's a bracket because that was a solid circle on the -7. And the parenthesis means you can't ever reach infinity. So anything you can't touch has a parenthesis next to it. You can go towards infinity, but you can never reach and touch infinity. So those are two problems. An equation, a formula rather, I should say, that you're told to solve for a certain variable, okay, or a basic inequality. Okay. The key was you're not required to, but I strongly suggest you always get X on the left-hand side. And then the rule was if you divide both sides by a negative, you have to flip the inequality symbol. All right, questions on either of those?
Professor,
Yeah.
in the second example, the answer, can you put as an answer parentheses, infinity, comma, -7 brackets? Can you
Ooh,
switch?
good question. No. Okay, but wait a minute. It's a great question because on your number line, this is supposed to be a kind of a mirror image of your number line. And notice -7 is on the left,
Yes.
infinity is on the right.
Okay.
So these two are the same. The other thing is just consider this. This is always the low number. This is always the high number, low to high, always. Okay. No, that was a great question because this is new to people. Okay. And there's all kinds of little subtle things. I wouldn't take off on a first quiz for that mistake. I'd correct it. But now that you've said it, great. Good question. I love it. Anybody else?
Yes, Professor. I want to know if you needed to divide or multiply in the beginning step of the second problem, is there any time in an equation where you flip the inequality more than once?
Okay, how do I answer this? Yeah, if you're wasting steps and going in circles. If you follow those 5 steps that I showed you about, getting rid of parentheses, getting rid of fractions and decimals, combining like terms. Remember those 5 steps I had for equation solving?
Yeah.
If you follow those 5 steps, okay, then you'll only have to worry about flipping one time, possibly in the problem. If you kind of do things in out of order, but don't make any crazy mistakes, then you might end up flipping it a couple times. Okay.
Okay.
But bottom line is, if you're flipping it a couple times, I would stop and start all over. Okay. Something screwy. You probably won't need to. Anybody else? These are good questions. All right, maybe that intimidates you. Those were good questions. Anybody got a bad question? No? Okay. Then let's erase this one and try this problem. This is another thing we talked about yesterday. I want you to solve this absolute value problem. 7 minus 3 absolute value. Whoops. 2x minus 4. Close absolute value equals -45. 44. Yeah, that's great. So we'll pause it and let you guys work on that. Okay, so the first thing with absolute value, actually, the first thing with anything weird, okay? For example, what if you had 7 minus 3 times the square root of 2x minus 1 equals negative 44 or something like that, okay? Or 7 minus 3 times the log of 2x minus 1, the logarithm, equals negative 44, okay? Anything weird that we're trying to solve, a square root, a logarithm. Some of you may know that, some of you may not. Don't worry about it. Anything weird, the first step is always get the weird part of this by itself. Always isolate the weird part, the square root, the log, or the absolute value. Okay, always isolate it. Okay, get the weird stuff by itself. Okay, by the way, we'll be doing problems like that later this semester. So I want to get the absolute value by itself. In order to do that, I first need to get rid of 7. So I subtract 7 from both sides. Remember, we had a discussion last night. You can't do 7 take away 3. Okay, that's violating equation solving. I'll explain it differently in a minute. But we do that. Anyway, take 7. You get negative 3, absolute value 2x minus 4 equals negative 51. Negative 44, take away 7. You lost $44. You lost 7 more, so you lost 51. Okay, we still need to get absolute value totally alone, so we need to get rid of the negative 3. So we're going to divide, because that's negative 3 times, so we're going to divide by negative 3, divide by negative 3. That gives me the absolute value of 2x minus 4 equals 17. Here's your calculator. Remember we talked yesterday, how do you know 3 goes into a number? If you add 5 plus 1, you get 6. Does 3 go into 6? Yeah, so it goes into 51. That's how you know how to test it. But the answer is 17 on your calculator. Okay, now the new thing we talked about yesterday was absolute values. Now that we've isolated it, gotten the absolute value quantity by itself, if the answer is 17, that tells us that this quantity inside could have been 17, okay, or it could have been negative 17, because the absolute value of 17 is 17, and the absolute value of negative 17 is also 17. So the inside could have been 2 possibilities, and we have to worry about both of those. So what we say is it splits into this equation, 2x minus 4 could have been worth positive 17, or 2x minus 4 could have been worth negative 17. An absolute value problem always, 99.9999% of the time, there's always a trick somewhere, but always splits into 2 different problems. Always. Okay, so we're going to add 4 to, I'm going to solve this problem. I'm going to add 4 to both sides and get 2x equals 21. Divide both sides by 2 and get, well, I could leave it as 21 over 2. Now, if you want to call that 10.5 or you want to call that 10.5, that's up to you. I don't care. 21, 2 does not go into 21, so I go screw it. I don't need to do any more. Okay, so I got 21 over 2. If you wanted to call it 10.5, or if you wanted to call it 10.5, totally fine, no problem. Move over to this one. We're going to add 4 to both sides. Oops. Let's do it in red for consistency. Add 4, add 4. So that's going to give me 2x equals negative 13. Negative 17 plus 4 is 13 negative. Divide by 2, divide by 2. Okay, x is negative 13 over 2. Remember, okay, we just have room. Remember, you bring these two together into your final solution set, 21 over 2, comma, negative 13 over 2. We split it up into two different problems to get the two different answers, but you always bring the two answers into a single solution area, solution set when you're done with the problem. Okay, that problem right there is like one of my favorites. There's always on exam number 1, always on quiz has been something similar to this. Okay, because I'm trying to see, do you know that you cannot subtract those? Do you know that? Okay. Do you know that you have to isolate the absolute value? Okay, all of these things I love about this problem. Any questions about that problem? Okay. One thing I do want to point out about absolute value problems. When we're down to here at this step, negative 3 absolute value, 2x minus 4 equals negative 51. Okay. It is safest if you guys just use this rule. Never, I know those are parentheses, but you never distribute into an absolute value. Never. Never. Okay. About 80% of the time you'll be wrong, and 20% of the time you'll be right. Those aren't very good odds. So it's safer that you just say in an absolute value, okay, I cannot distribute into an absolute value. 80% of the time, that'll give you the wrong answer. Okay, so just don't. Okay, it's, well, I won't tell you why and whatever, just don't. Don't distribute into the absolute value. You'll get it wrong every single time, or 80% of the time at least. Okay, I want to move on. That's it for my review. Anybody have any questions? Okay, here we go then. I want to do some simple word problems. I asked you guys to download that worksheet. I hope you have it. My Zoom is acting really weird. I don't know if you've noticed it over the last couple of days, but it kept freezing on me. It wouldn't let me quit. So my recordings went on for 10 or 15 minutes and we weren't doing anything. Okay. And it takes too long to edit them. So I just have stupid recordings up there that are about 15 minutes too long. I apologize. So anyways, I went to Zoom people today and said, hey, what's happening? And they said, okay, well, we'll fix it. And so what I did was I uninstalled old Zoom, reinstalled a new super version of Zoom, and they said, try it and come back to us. Well, the problem with this new super version of Zoom is it's got all these features that are just a little bit different than the old version. So the bottom line is, I don't know quite what I'm doing. It won't do what I wanted it to do. It should, but it won't. I can't figure it out. So I'm kind of stuck. What I was hoping to do was take those 4 problems on the worksheet, okay, and one at a time, copy and paste them into the chat. Okay, so if somebody has that available and can do it, that would be appreciated, just one at a time, okay, as we do the problems. I just, copied it, pasted it in there and said, here it is. But my Zoom isn't letting me minimize so I can go to the file on my desktop. And I don't want to take the chance of losing my connection, losing you guys. So I'm just not going to do it. So, but like I said, if somebody has that and can put the problems one at a time into the chat, that would be wonderful. Okay, I'm going to erase this to make room. Quizzes tomorrow night. It will be on Mom. It will be on Mom. I'll quit talking probably even before 8:30. Okay, you don't know how hard that pains me to stop talking. Okay, hurts me, but it will be covered chapters 1 and 2. So make sure you're here tomorrow night. Okay, it will be timed. Okay, I'll talk more about that tomorrow night. All right, the first question on that worksheet that I want to go over, it said, actually, let's take a chance. Let's, I just bought something brand new. Okay. Let's see. I want to do problem number 1. Okay. The problem with this is you can see it. Okay, but then I have to switch back to my screen so you can see it on the whiteboard. So I'm going to do problem number 1. It says the perimeter of a rectangle is 45 inches. The length is 12.8 inches. I want you to find the width and find the area. Okay, pretty basic thing, but I want to show you the proper way to do it. Okay, so take a second to copy that down. The perimeter of a rectangle is 45 inches. Okay, the length is 12.8 inches. Find the width and find the area. Okay, let's go back now to that camera. Yay. So if I can, I always draw a picture. Always. It helps me think. Okay, it talks about the perimeter is 45 inches, but then it says the length is 12.8 inches. Okay, so there's a picture. The perimeter is 45 inches. The length is 12.8 inches. Now, one of the things I said last night is this should be a formula that you have memorized. And the formula is P equals 2 times the length plus 2 times the width. So your job then is real simple. You plug in. A lot of people, okay, and maybe it's just me, maybe it's because I'm old and whatever. A lot of people, when I say, what's the formula for the perimeter? They go 2 times the length plus 2 times the width. Wrong. The formula is P equals 2 times the length plus 2 times the width. Okay, for example, if I said, what's the formula for the area of a circle? Pi r squared. Wrong. The area of the circle formula is A equals pi r squared. It may seem like real nitpicky, okay, the old farts are really worried about this crap again, okay? But it's really important because the formula tells you what to plug in where. So back to this problem, okay? The 45 goes right here under the P. Equals 2 times 12.8 plus 2W. So having the formula shows you where your numbers go in the formula, where to plug them in. So we get 45 equals, this is use your calculator, that's going to be 25.6 plus 2W, I think. Okay. Subtract, where is it? Subtract 25.6 from both sides. Let your calculator do all the work. I will. I think it's something like 14.4, but I don't trust myself. 45, take away 25.6. 19.4, I wasn't even close. That's why I don't trust myself. 19.4 equals 2W. So we're going to divide both sides by 2. Okay, and on my calculator, divided by dose is 9.7. Now, a couple things here. The 9.7 is right, but it's wrong. If you circle 9.7, you'll lose credit. I don't think I've made any mistakes. I hope. Okay. Started with the full formula, the entire formula. Okay. Plugged in my numbers, worked down, did my algebra. That's wrong. This is a word problem. It has units in it. So you need to say something like width is 9.7 inches. That's important, inches. Whether or not you say W is or you just say W equals, I don't care. Okay, but you do need the inches, IN, the units. That's going to be real big. Okay. The next question was, what's the area? Well, what have we just figured out? Okay, we figured out that the length is 12.8 and we got the width is 9.7. Okay, so the formula for the area is length times width. So 12.8 times 9.7 is, calculator time, here. Mm-hmm. 124.16. Okay, you're wrong. Again, wrong. 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 Okay, I've made no mistakes, but I'm still wrong. Why am I wrong? I'm sorry? You cut out.
The units.
Right, what would my units be?
Inches.
Wrong.
Inches squared.
Inches squared. Okay, for two reasons. Okay, inches squared. I'll show you why in a minute. The actual answer is area equals 124.16. Okay, old traditional people would write squa in. New people write 124.16 inches squared. Whichever. It doesn't matter to me. That's the old style, square inches. The new style is say inches to the second power, inches squared. But you do need that. Now, let's talk about why. Okay, when you, there's two reasons why. Way back, okay, way back in elementary school, when you started talking about area, maybe it was middle school, whatever, they showed it to you as how many squares fit in there. Okay, and so you said there was 6 squares, okay, that were inside that, and it happened that we're all 1 inch in dimensions, 6 squares that were an inch on each side, or a centimeter, or a foot, or a mile, or whatever. Okay, the inches says what was the size of each square. Each square was 1 inch on a side. There were 6 squares that were 1 inch on a side. That's how we got the 6 squa in. 6 squares that were 1 inch on every side, or 1 centimeter, or whatever it was. So going back to either elementary school or middle school, or whenever you learned your area of formulas, okay, they always introduced it by saying there were squares in there. So even when we're doing it here and we're not drawing all the silly squares, we still refer to those squares. That's why we need them here. Squares that were 1 inch on a side because our units were inches. Now there's another more mathematical way of showing that. Okay, first off, does everybody know that x times x is x to the second power? Okay, just like 5 times 5 is 5 to the second power. Well, it turns out that inch times inch is also inch to the second power. Units can multiply. So if we had 12.8 inches, if we weren't lazy like I was, and I actually wrote 12.8 inches times 9.7 inches, I would have 124.16 inches times inches, or 124.16 inches squared. That's a math or science way of showing you how to get the proper units. Okay, inches or inches squared like that. Okay, it's really cool when you're talking about volume, because volume has 3 dimensions: length, width, and height. Inches times inches times inches, 3 of them. Inch times inch times inch is inches cubed, or centimeters to the third power, or whatever you have. So this concept of multiplying your inches and using a power really is neat in a lot of higher level math classes and science classes. Whatever, enough BS. You just have to remember that you need to get the proper units on your answer. Okay, whether you put them in your problem or not, I don't care. Okay, but you do have to put the proper units on your answer. All right, any questions about that one? Okay, then let's switch over. See if this works again. Uh-oh. Come on, come on. Yeah. Tell me you froze. Yep. Oh, they're it. Come on. Well, didn't do any good. So I'm not going to mess with it. I'm just going to do the rest of it. For some reason, they didn't like that. Okay. All right. So the second problem, nobody's put in the chat, or I can't see chat. Oh, that was good. You really screwed it up now, Foster. Mm-hmm. You're really effed it up now, buddy. Okay, I don't know if you can hear me, but
We can hear you.
I am logging myself out of Zoom and trying to get back in. So hang on, bear with me. I promise I won't screw with this again tonight. Where's Zoom? And then let me stop Zoom. Hmm. I don't even see Zoom there. How can I stop it if it's not there? Ah, yeah, screw it. I'm back. Can everybody hear me?
Yes.
Yes. Yay. I'm never going to screw with that thing again. Hang on a minute. Okay. And that. Video there. I'm real sorry for the disruption, everybody. And again, there will be a gap in the middle of my stupid recording and whatever. All right. So sorry. Hope we're all back. All right. Next problem, which I hope you downloaded and will do. I'll just write it up here. Number 2 says the area of a circle. Says the area of a circle is 276 inches squared. It says use pi equals 3.14. We want to round our answer to the 100th. And the first thing we want to do is find the radius. So the picture here, something like this, we want to find the radius. We already know the area is 276. So our formula is area is pi times the radius to the second power. So we plug in 276 equals 3.14 quantity times r to the second power. So that's plugging in everything that the problem said to do. It told us the area was 276, so that's what I plugged in. It told me to use 3.14 within the problem, 3.14 in place of pi. So I want to solve. Now, this is a kind of an interesting problem. Mathematically, we're going to divide both sides by 3.14. Okay, so whip out your calculator, 276 divided by 3.14, enter, and I get, and I hope somebody confirm, okay, 87.89808917 equals r to the second. I copied that, 87.8980, okay, 8917, yeah, okay, and it goes on, whatever. Now, this brings up a new thing that we have to discuss. Everything in math has something that cancels it. For example, if you say 3 times x, how do you cancel the 3? You divide. They cancel out, you get x. If you had x plus 5, how do you cancel out the plus 5? With a minus 5, x minus 5. This still becomes x. Every operation that we do in math, okay, has something that completely cancels it out. So for us, the thing that cancels out a square power is a square root. Okay, you're going to square root both sides. So you have a square power. To cancel a square power, you have to square root it. Okay, so square powers and square roots cancel. Let me write that up. If you have x squared, but you square root it, you get x. If you have the square root of x, whatever that is, and you square power it, you still get x. Square roots and square powers always cancel each other out. Okay, and you get x. And that's a lot of discussion in chapter 8. We're going to go a lot more into powers in chapter 8. But right now, we're going to square root both sides. So Okay. I'm going to go, yesterday we talked about the square root, which is second x squared. Okay. And oh shoot, I can't show you guys how to shortcut it. Okay. Okay. I'll try and show you how to shortcut it if you can. Anyway, I get 9.375398081 equals R, because you square rooted both sides. But the problem says round to the hundredth. Round to the hundredth. So here we go back to that rounding that was on the quiz. The 7 is in the hundredths place. So you look to the 5. Is the 5 big enough to round it up? Sure is. So 9.38, and our units were inches. Okay, inches. Our units were inches. Anything that's a straight line is an inch. Anything that's an area is inches to the second power. So 9.38 inches was our radius. Okay. Again, I'm afraid to do this. I really like to show you this on my other camera, but Zoom is working now. I don't want to screw it up. But I want to show you this. If you have the TI-36X Pro, other calculators have this feature. You just got to find it. Okay. Earlier, we did this problem. 276 divided by 3.14 equals R squared. And that's how we got this big old ugly answer. 87.89, blah, 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 blah. I'm not going to write it up, equals R squared. Okay. On your calculator, well, okay. On your calculator, on the TI-36, okay, right above the minus sign, whoops, down at the bottom, it says in blue, answer. And what that means is your last answer. So if you said, okay, now I want to take the square root of this. Yesterday we talked about how to get the square root. And instead of typing in all of that ugly decimal, instead of typing in 87.898089117, blah, 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 you could type in, or you could hit the answer key. And notice it's second minus sign. Whoops, sorry. Because it's in blue. That answer is the blue, so it's second, which is right above that thing. And that will automatically take the square root of your last answer that you had on the screen. It will automatically take that, so I don't have to type in that long ugly decimal. Now, maybe my explanation isn't real good right now, but you could certainly try at home. What's 8 times 3? Well, that's 24. You could say that's answer. So you could say, what's the square root of 24? Answer. Okay, and test it out. The square root of 24 is, I don't know, something like 4.9. Let's try it. Square root. Okay, FD. 4.89, something or other. So you could test it out with smaller numbers that you can double check and make sure you're doing it right. But that's a really neat feature. Other scientific calculators have that, so you don't have to type in long, ugly decimals twice. But anyway, so that was the first one. It said find the radius. The second half of that question was find the circumference. Okay, so our formula for circumference is C equals, we have two of them, 2 times pi times r, 2 pi r, or pi times d. Those are the same. Okay. However, we have the r. So plugging in what we have or don't have, okay, using this, circumference is 2 times 3.14 times 9.38. Circumference, we figured out the radius, so we're going to use it up here in this formula. And that's just a matter of cranking all that on your calculator. So 2 times 3.14 times 9.38. And I get 58.9064. But if I round that to the nearest hundredth also, that's in the hundredth place. So I look at the 6 kicks it up. So 58 point, that rounds to 91, and this is inches. Circumference is that inches. That was number 2. Question. Okay, number 3. Number 3 says, in a triangle, the second angle, so number 3, in a triangle, says the second angle is twice the smaller angle. Okay. The third angle is 35 less than the second angle. Okay. Find smallest angle. Let's see. So my handwriting is really crud, but I'm really hoping you guys downloaded that worksheet. It says in a triangle, the second angle is twice the smallest angle, the smaller angle. Okay. The third angle is 35 less than the second angle. And they want to find the smallest angle. So here we go. So angles, okay, I just could draw a triangle. Angles are measured inside. If you put X out here, for example, then you're telling me the side is X. But if you put X here, then you're telling me that angle is X. Technically, it's X degrees. Okay, so you need to be careful where you put your variables on your picture. X on the outside, okay, means you're talking about the length of that side is X. X on the inside, like that, means that angle is measured as X degrees. Okay, so I'm going to just call that randomly. I just said, there's my X, there's my smallest angle. That's my smallest angle right there. There's X. So let's move to the second angle. The second angle is twice the smallest angle. All right, the question is in English, what does the word twice mean? Twice means times it by 2. So the second angle is actually 2x. So here's the smallest angle. My first angle is x, which is the smallest. My second angle is twice x. Twice means 2 times. Where's my colored pen? Okay. Twice means 2 times. Now, the third angle is down here. This is the third angle. Okay. But it's a little bit tricky. It's 35 less than the second angle. Okay. Well, we already know there's the second angle. This is it right here. This is the second angle. But 35 less than. Okay. In algebra, if you say 35 less than R, you to R subtract 35. Less than means subtract. Okay, less than means subtract, but it's kind of subtle. It's an English, it's a subtlety of the word than, or the emphasis of than as an English modifier of the verb here. Less than. It means if I'm okay, I'm 5 inches shorter than my son-in-law. Okay, so my son-in-law is here. I take away 5 to equal me. Shorter than. You start with the son-in-law, you take away 5, that will be me, shorter than. Less than R, you start with the R, and then you get smaller than the R. So it's got to be reversed, R minus 35. So back to here, what am I talking about? The third angle is 35 less than the second angle. So the third angle here has to be the second angle less 35. This whole thing represents the third angle. So let's go back over this. Somebody always has to be X. And if you read this very carefully, everything was in terms of the smallest angle. Okay, the second angle was reliant upon the smallest angle. The third angle was reliant upon the second, which was reliant on the first. So the first angle was the key, that's why it was X. Second angle was twice, that was 2 times. Third angle was 35 less than the second angle. So whatever that was, less 35. So that's the one thing, that's the setup. Now, where in the world is the equation? One of the facts that you need to know, what do the 3 angles of a triangle always add up to be? The 3 angles of any triangle, no matter how I draw it, what do they always add up to be? Anybody know?
You said 180.
180. Excellent. No matter how you draw the triangle, if you draw a right triangle, okay, you have X plus Y plus the 90 degrees has to equal 180. If you draw a bizarre scalene triangle like that, so an obtuse scalene triangle, you have X, Y, and Z. The 3 angles, X plus Y plus Z, always equals 180. That's a fact of every single triangle in creation. The 3 angles always add up to 180 degrees. So in our problem, the 3 angles are X, that was the first one, plus 2X, that was the second one, plus 2x minus 35. That was the third angle. Those are the three different angles, and they always have to equal 180. The three angles add up to 180. Well, once you do that, now this is just basically an equation that we've solved for like a week now. So you add like terms, x plus 2x is 5x minus 35 equals 180. Add 35. So I have 5x equals 215. Is that right? Yeah, that's right. Divide by 5. Okay, see if I can do it by head. 5's cancel out. That becomes 43. Somebody, I better double check on my calculator. I don't want to be dumb. Okay, 180. Let's go back to there. 180. Come on. 180 plus 35. 215 divided by 5. 43. Okay, the last thing I want to talk about is when you're measuring an angle, you have units. Like when you're measuring a line, your unit is inches or centimeters or feet. When you're measuring an angle, your units are degrees. That funny little circle up there means degrees. Okay, so you could say either 43 with a dumb little circle, or you could say 43 degrees. That's up to you. But your unit, you're measuring degrees, not feet, not inches, but degrees. So this problem, there was a couple things here. The first was translating the English into math. Twice meant 2x. 35 less than meant subtract, but change the order. Then you had to put those words on a triangle. Okay. Remember, somebody is always an X. Put X somewhere. It's just X is there somewhere. Okay. Then we had to know that the three different angles, this was the first angle, this was the first, this is the second, and this is the third. The three different angles always add up to 180 degrees. I should have put that up here, degrees in a triangle, always. So we just solve it. And for our final answer, we use the units of degrees. All right, I am talking fast because I lost some time there. Take a deep breath. Okay, questions? Let me get through one more, then we'll take a real short break. Okay. and then
Professor,
Yeah,
so you can just add straight, you don't have to multiply the 2x plus times the 2x that's inside the parentheses?
no, because remember, these are adding together. If this had been x plus 2x times 2x minus 35. Oops. Okay. If it had been there and there had been implied multiplication, then you'd have to multiply that. But this was just addition. So you're just adding the like terms, 1x and 2x and 2x.
Okay, thank you.
Okay. By your kind of silence, I'm gathering I didn't answer your question very well.
Yes,
You're okay?
yes.
Okay. All right. Anybody else? Again, I was talking fast. I apologize. Make me clarify something if you need it. Okay. Last word problem. Then we'll take a quickie break and then come back with the chapter 2 stuff. last word problem here, number 4. It says in a right triangle, number 4, in a right triangle, the hypotenuse, which I can't spell, so I just do it, is 234 centimeters. Okay. One leg is 87 centimeters. Find other leg. And it says round to the 1,000th of a centimeter. We'll worry about that later. All right. In a right triangle, the hypotenuse is 234 centimeters. One of the legs is 87 centimeters. And they want me to find how long is the other leg. All right, this is a key question. There's some key words in here. The idea of right triangle and hypotenuse. Those are giveaway words. What that tells us is our triangle, okay, looks like this. There's a right angle, and the hypotenuse is always opposite the right angle. Wherever the right angle is, the right angle measures 90 degrees. Okay, the hypotenuse is always the side opposite it, and these are called legs. Now, I talked about this last night, but I know some people were asleep, or at least that's what your email to me said. Okay, other people, it was new to you, so I'll review it again. These are called legs, L-E-G. This is a leg. This is a leg. Okay, and that's the hypotenuse. Well, when you have that condition, you can use what we call the Pythagorean, P-H-A-G-O-R-E-A-N, and it's either called a formula or a theorem, depending on what you learned, if you learned this in high school or wherever you learned it. It's by this Greek guy named Pythagoras. He developed the formula. And his formula, like I showed you last night, was you take leg squared plus leg squared, and it equals hypotenuse squared. Okay. In high school, we learned this as a squared plus b squared equals c squared. Notice in the formula, the hypotenuse is always the one by itself. The hypotenuse is always what it equals, hypotenuse squared. Okay, so I personally prefer the top formula, okay, because it tells me clearly what are the legs, where I stick the legs and where I stick the hypotenuse. A, B, and C don't tell me anything. They're just 3 sides. Okay, and I don't know where to stick my numbers. So I stick them first and last. Where do I do? So I like the top formula better, but that's up to you guys. I'm not going to force that on you. So anyway, in this problem, it says hypotenuse is 234. So we do 234 squared, and it equals one of the legs. It doesn't matter which one, 87 squared, plus this other leg squared, which I'll abbreviate it as L squared for leg squared. So that's taking the formula, plugging in the appropriate numbers. The hypotenuse has to be 234. It doesn't matter where you put the legs. A leg is a leg. It doesn't matter. Okay, it's going to work out. So you whip out your calculator and you do some work here. Okay, 87 squared. I get 7,569 plus L squared equals, okay, 234 squared, 54756. Okay. Algebraically, we would take away 7, 5, 6, 9 from both sides. Thank God we have a calculator. Where's my glare? It's down there. So I get L squared equals, okay, this minus 7, 5, 6, 9. And I get 4, 7, 1, 8, 7. Okay, now we're back to that same thing that we did earlier. We want to get L, the leg. Okay, we have to get rid of the square power. Like I said earlier, the square root cancels the square power. So if we square root this side and square root this side, this will get us L equals. Okay, and you can try that answer button if you want. Okay, no, stop it. Square root answer. And I get 217.2256 something or other. 217.2256891. Is that showing up on the screen? Yes. Okay. Last thing, and then we'll get some questions and we'll take a break for a few minutes. The problem said round to the thousandth of a centimeter. Oh, crud. Where's the thousandth place? All right. Remember, decimals start at tenths, hundredths, thousandths. So the 5 here is in the thousandths place. So I check out the 5, but I actually look behind it and ask, does 6 round the 5 up? The answer is yes, it does. So my other leg is 217.226. And my units, I believe, were centimeters. So I got to talk about a whole lot of stuff here, okay, in all of these problems. Always start with a formula. We introduce the concept that everything's got something to cancel it, squares and square roots, okay? And we got to talk about right triangles and Pythagoras again. Any questions about any 4 of these problems? We just did 4 problems. All right, let's take about a 4, maybe 5-minute break. It's almost 8 o'clock right now, so let's come back at 8:05. Okay, 8:05, 8:04, somewhere. Come back and I'll start talking definitely about chapter 4. We're going to go chapter 4 right now. Okay, and I'm not going to touch Zoom at all. Leave me alone. So 5-minute break, guys. Sorry. Okay. Quick review here. In chapter 1 and 2, we focused primarily on what were called linear equations. Now we had some inequalities and we had some absolute value, but primarily we had a linear equation. Okay. And it had one answer. That's the key idea. What's called a linear equation has one variable and one answer. And that meant the only thing that could make this problem true is if X were 8. That's what we were searching for. What makes the problem true? Well, doing some algebra, X is 8. But in chapter 4, we're going to jump to equations with 2 variables. 2 variables. So for example, we're going to have X plus 2y equals 6, for example. An equation with two variables, x plus 2y. It turns out that there's an infinite number of solutions to this. Okay, there's an infinite number of solutions. Okay, for example, if x were 6 and y was 0, if you plug that in, you have 6 plus 2 times 0 equals 6. Well, that works. That's true. Yes. What if y was, or what if x was 0 and y was 3? So we have 0 plus 2 times 3 equals 6. That's a yes. And there's many, many more. For example, what if x were 8? This is a little nastier now. What if x were 8? Then we'd have 8 plus 2y equals 6. Take away 8 from both sides, 2y equals -2. Solve, divide by 2, we get y is -1. So y is -1. When x is 8, y is -1. And we could keep going. I just randomly pick these numbers. Okay, as a matter of fact, that's going to be one of the questions that mom asked you. She's going to give you an equation. Like I did here. I don't know. Let's use the same one, x plus 2y equals 6. And she'll say, hey, if x is 10, can you figure out what y is? Now, one of the things we all need to agree on is when we write this, the first number always represents the x, and the second number always represents the y. Always. Okay, this is called an ordered pair. Pair means two. Order means the order is important. X is always first, y is always second. So anyway, mom is going to give you some crazy equation and say, hey, if x is 10, can you figure out y? And that's real simple. You just plug in 10 for x, just like a formula, plus 2y equals 6. Solve it, take away 10, so 2y is -4, y is -2. Okay, use whatever algebra skills you have to solve that problem, y is -2. Okay, then mom's going to get weird. She's going to say, oh, okay, for the same equation, okay, what if y was 5? Can you figure out what x is? So go ahead and take a second. If y is 5, using that equation, can you find x? And I get -4. So I'm going to copy these over here. I have 10, -2, and -4, 5, -4, comma 5, because I want to use these in a minute. So one of the things that mom is going to start with in chapter 4 is she's going to talk about equations in two variables. Okay. And she's going to say, is this a solution? Yes or no? And she's also going to say, hey, if x is 10, what's y? If y is 5, what's x? And so for you guys, it's just to plug in and do arithmetic. That's all it is. Plug in, do arithmetic, find out whatever's missing. But I started this by talking about equations with two variables have infinite solutions. Okay. It would be wrong of me to ask you to give me all of the solutions. You couldn't. Now, for a linear equation, you could give me the solutions. Piece of cake. Okay. But for an equation with two variables in it, you can't possibly give me the solutions because there's an infinite number of them. So what we do instead is we introduce the concept of a graph. Okay, so we graph these on an XY axis. Remember, this is called the x-axis, and this is called the y-axis. Okay, and there's a number line. This is 1, 2, 3, so on. There's numbers here. Now, I'm not going to be very accurate. If you want to be accurate, get some graph paper, okay, whatever, but don't worry about it now. So let's plot these points. Remember, the first number is always the X number. The second number is always the Y number. So we're going to plot these points. So the first point is 6, 0. 1, 2, 3, 4, 5, 6, 0, which is right about there. Good enough. Okay. The next one is 0, 3. Okay. 0, 1, 2, 3. Remember, the first number is the X, the second number is the Y. So this is literally saying we always start from, that's called the origin, where the two number lines cross each other. We always start from there. This is saying go 0 in the X direction, then go up 3 in the Y. That's what 0, 3 is. Okay, let's keep going. 8, -1. Okay. That was 6, 7, 8, -1. 10, -2. Well, that's off my screen. I don't know what the hell that is. That's somewhere like out of here. -4, 5. 1, 2, 3, 4. Okay. So I'm plotting points, which most of you have seen before. Somehow I'm plotting all of these possible, well, they're not possible, they are solutions. And I've listed only 4 or 5 of them. All right, what is true about those sets of dots? What do you guys see up there? Anything besides a mess?
They all line up with each other.
Okay, they all line up with each other. You can't believe how important that statement is. Okay. When we say graph an equation, we are asking you to show me a representation of all of the possible ordered pairs that might make this problem true. Remember, there's an infinite number of them, an infinite number. And we've only put up 5 of them, but they give us an idea that says, okay, the answers to this problem are all going to be on this line. And the line goes forever, negative and positive, whatever, positive, negative. But we get lazy in math. Instead of putting a bunch of dots up here, because that's actually what we're finding, we get lazy and we just draw a solid line. And this is where you, as the mathematician, have to understand a line is actually made up of infinite little dots. And all of the invisible little dots that we can't see up there, all of those little dots represent solutions to that equation. Okay, big philosophy lesson here. An equation in two variables has an infinite number of solutions. We can find some of them using some algebra. We can find some of them. But if we want to see all of them, then we draw a line through a couple of them, and that line shows us all of the answers. All of the solutions for this problem are going to be found on this line. So it's a graphical representation of the infinite solutions for this line. Okay, that's kind of a key concept. A graph is a picture of the solutions. A graph is a picture of the solutions to an equation. Okay. Theoretically, by the end of chapter 4, I should be able to give you an equation. You should be able to find a couple of obvious points and then graph it. Or I should be able to give you the graph, and you should be able to give me the equation. That's what we're going for, because they're the same. An equation represents a bunch of ordered pairs, which can be put on a graph, which means we can reverse it. A graph is made up of a bunch of ordered pairs, points, dots, so we should be able to find its equation. And that's going to be one of our major goals for chapter 4. Graph an equation, and then if I give you the graph, can you find its equation working backwards? Okay, that's big idea number 1. Okay, big idea number 2. We've got a lot to cover here. Okay, okay, so wait a minute, let me stop for just a second. So one of the things Mom was going to ask is, if I give you equation, whoops, (2x plus 5y equals 29. Okay, is 7,3 a solution? That's going to be one of the things Mom is going to ask in the homework. Give you some equation, and I just made this one up, and ask, is 7,3 a solution to this equation? So take a second, see if you can figure out if it is or isn't. Is it? Is 7,3 a solution?
Could you say it's just one of the possible solutions?
Yeah, is it one of the possible solutions? Yeah, that's what I'm asking. You rephrased it better than I did.
Yes,
Is it? Okay, how do you know? How can you say yes?
I applied 7 to x equals 7
Okay.
and y is
Good.
equal 3.
So 2 times 7 plus 5 times 3, does it equal 29? So 14 plus 15, does it equal 29? Yes. So this is a solution. So that's what Mom is going to give you. She's going to give you an equation, an ordered pair, and say, is this one of the solutions to this? And your answer is either yes or no. That easy. The next thing Mom is going to do with the same problem, so this is yes. she's going to say, find the missing variable. If this is 10, comma, figure out the missing y value. Okay, so take a second and see if you can figure out that. It will be a fraction. Anybody think they got the answer?
9/5.
That's what I get. I got 9/5 or 1 4/5 or 1.8, your choice. So what I actually got was 10, comma, 9/5. Does anybody need to see my work for how I got that or how we got that? Are you, okay, so you want to see the work for that? So real quick, we have this equation. We have 2x plus 5y equals 29. You have to know that this 10 represents the x. The first number, the first part of the ordered pair is always x. So this is 2 times 10 plus 5y equals 29. So 20 plus 5y equals 29. Am I in the glare yet? Yeah, I am. Take away 20 from both sides. I have 5y equals 9. I'm out of the glare. Divide by 5, and I get y is 9/5, which is what we got. So what this is saying is when x was 10, y turned out to be 9/5. And again, whether you showed it to me as a mixed number, 1 4/5, or a decimal, 1.8, I don't care. So that's what we did. We just simply plugged 10 for x into this equation and figured out y. So those are things that mom is going to do right at the beginning of chapter 4. Okay, I extended this to give you a philosophical answer. An equation represents a whole bunch of dots, a whole bunch of things that make it true. Not just one thing makes it true, but a whole bunch of things make it true. So the equation, the graph is a picture of all of the dots that make a problem true. Okay, so that's in the first part of chapter 4. Now I want to go off the deep end for just a second. I want to go off the deep end. I want to talk about some important concepts that you're going to run into in mom either, well, this weekend for sure. I'm not sure about tonight or tomorrow. And it's got to do with, remember I started talking about functions the other day? Okay, and we had things like f of x equals x minus 3 over x plus 2. We had these functions, f of x equals this math rule. Well, there's something that goes along with this, and that's the concept of domain and range. Okay. Domain is a list of all possible x values. Range is a list of all possible y values. So important vocabulary words. As you move higher and higher in math, the study of functions is going to be more and more important. And when you study functions, we always include the idea of domain and range. So this is two vocabulary words you absolutely need to know. What does a domain mean? What does a range mean? So I'm going to give you some examples. Domain is X, range is Y. So one example, I might give you this, f of X equals, okay, now I'm being weird here, 3, 1, 7, 8, 4, -1, 0, 5. Oops. So instead of my giving you f of X as a rule, I'm giving you f of X as this. Okay. The domain of this picture, remember, domain is a list of all possible X values. So in this problem, your domain would be 3, 7, 4, 0. It's that easy. Domain is those numbers. 3, 7, 4, 0. The range would be 1, 8, -1, 5. Because the domain and range is a list of all possible X values. So here is the simplest example I can give you. Here's some function, something, and I've given you its ordered pairs. So all you had to do was pick out the domain is the X's and the range is the Y values. That's domain and range. Okay. So the question all mathematicians ask is, okay, that was easy. What can I do to screw you up? That's what we always ask. What can I do to screw you up? Well, what if I gave you a different picture? What if I gave you this triangle picture? And I said, this is some f of X. I don't know what it is. It's the graph of something crazy, but it makes this triangle. And let's say this point over here is -6, -3. And let's say this point here is 3, -1. I'm just making this up. That seems reasonable. Okay, and let's say this point here is 0, 3. So I just made up some ordered pairs. I drew a triangle up here and I just said, that looks like -6, -3. Back -6, down 3. This looks like over 3, down 1. And this looks like 0, 3. Remember, everything is measured from the origin. You always start there. So from here to here, it looks like I didn't go sideways, but I went up 3. Okay. So now, here comes, remember I said I'm going to try and mess with your heads. What's the domain and range of this picture? It was easy when I gave you these points. Hang on, I'm going to show it to you. And then I'll have you guys try one or two. Okay, the domain and range of this. Domain is all of the X's. So hold on. The X's, okay, go from -6 to 3. Think about this. If you look at this picture, all of the X's from -6 up to 3 are being used. And it's not just individual little dots, not just single dots, it's every little fraction, every little decimal from -6 up to 3. Those are the X's that are being used in this picture. Everything, whether it's above the line or below the line. So in this case, hang on to your horses, the domain, okay, is bracket -6, 3 bracket. Okay, because I want everything in between -6 and 3. Not just a few points, not just 1, 2, or 3 individual little points, but I want to talk about everything, every fraction, every decimal. So we use interval notation as our way of listing all possible x values. The left x is -6, the right x is 3. Okay. With that, what about the range? Now, the range means all possible y values. So question, what's the lowest y value?
-1.
Nope. How about -3?
Oh, yeah.
That's the -3.
Yes.
And if we go up, we'll use the 1, we'll include the 1, but what's the highest y value?
3.
3. So the range goes from -3 to +3. The range on this picture, all of the y values are everything between -3 and +3, and it picks up that automatically. The -1 is just automatically included. So for the range, we say from -3 up to +3. And we have to use interval notation because we have an infinite number of fractions and decimals, everything in between those two numbers. Everything. Let's try one more, and then I have something for us to do. So if I give you individual little points, then it's easy to pick out the x's and the y's. If I give you this ordered pair, x's and y's are easy. But if I give you a picture, x's and y's aren't so easy. You've got to do a lot of analysis, a lot of thinking. This is actually a very high-level thought problem. The domain means all of the possible x's. Well, the smallest x is -6, the biggest x is 3, and x is everywhere in between. So I represent that with interval notation. Same thing with my y's. The lowest y is -3, the highest y is +3, and everything in between. So I represent that with interval notation. So having said all that, let's try this. Okay, new picture. Okay, let's take an ellipse. And this point looks like 10, 5. And this point looks like, oh, I don't know, -2, 5. And I want to come down here like this. And this point, which is the lowest point, looks like, I don't know, 5, 1. I'm making this up, guys. And this point up here, this looks like 5, 7. Okay, it's an ellipse, a football, an oval, whatever you want to call it. Okay, so take a second to see if you can come up with an interval notation that represents the domain and the range. Okay, anybody want to take a shot on the domain?
-2 to 10
Okay, and what goes on either side of those
brackets.
brackets? Because we're going to
Right.
touch it.
Yeah.
Good, that's perfect. You guys see that the lowest x was -2, the highest X was 10 and everything in between was used. That's why we said that. Okay, range.
Brackets 1, comma 7, and bracket.
Yep. Again, I agree completely. Everything in between from 1, which is like right about there, to 7, which is right about there. Everything from 1 to 7, all of the Y values are going to be between 1 at the low end and up here 7 at the high end somehow. Okay, that's the concept of domain and range. Domain, you need to know that. Domain stands for all possible X values. And either you can list them individually, 5, 7, 6, 3, or you use interval notation if you have an infinite amount. Okay. Oh, crap. I want to do something, but I'm afraid my computer is going to blow up. I don't know what Zoom is going to do to me. All right. I'm not going to do that tonight. I'll get it fixed and do it tomorrow night. One more thing, and then we go home, and that's it. One more thing real quick. Okay. One more. So hang with me. So are we kind of okay with domain and range? I mean, I'm going to keep going over this and we're going to keep working on it because it's an important concept, but I understand I just threw something at you that's really new and really weird. Domain is our way of talking about all possible X's. Range is all possible Y's. So I need to erase the board. Okay. In chapter 4.2, Mom wants you to graph lines by building a table of values. Okay, so let's take an easy example. Let's take 2x minus y equals 6. Now, sometimes Mom will actually give you the value. Sometimes Mom will say, hey, what if x is 3? Then you just deal with it. If x is 3, you plug it in. 2 times 3 minus y equals 6. Okay. We get negative y equals 0, which means y is 0. So this gives us our ordered pair. xy is 3, 0. Now, the plug-in is just arithmetic. You don't have to show this, but you sure as heck have to think this. So sometimes Mom will give you an x. You're going to plug it in. You're going to fill the table in with a 0 because that's what your math showed. And then you're going to give her the ordered pair, 3, 0. Okay. And then Mom's going to give you another one. Sometimes Mom will give you the y value, 12. I'm making these numbers up. Mom will give you the x. You plug it in, figure out the y, write an ordered pair. Now she gives you the y is 12, so you plug it in. 2x minus 12 equals 6. Add 12, 2x equals 18. You can solve that in your head. X is 9. Divide both sides by 2, x is 9. So your ordered pair out here, your x comma y is 9, 12. So again, sometimes Mom will give you an x and you calculate the y. Other times she'll give you the y, you plug it in and calculate the x, And other times she'll just say, hey, pick some on your own. Pick some. Well, let me give you a little hint. If you're allowed to pick something on your own, always, almost always pick 0. If X is 0, it makes your arithmetic easier. Almost always pick X equals 0, if you can. So you plug it in, 2 times 0 minus Y equals 6. 2 times 0 does it, so I get negative Y equals 6. But if negative Y equals 6, that means Y is negative 6, because you divide both sides by negative 1. So I have 0, comma, negative 6. So again, going back in chapter 4.2, Mom wants you to graph lines by building a table of values. Fortunately, there's not too many of these, but there's enough of them. Okay, there's a few. Okay, build a table of values here. Sometimes she'll give you the X, you figure out Y. Sometimes she'll give you the Y, you figure out X. And sometimes she doesn't care. So you pick any number you want. I strongly suggest you pick 0 and plug it in. Okay, that's it. Now, the next thing on that practice quiz, it showed you how to graph a line. It talked you through it. The first thing you do is you pick a choice of, do I want a line, or do I want a parabola, or do I want a circle? You pick the one you want, click. Okay, so you click on that one. Okay, then you pick one of these points, 3, 0. Click, and a line will show up. Okay, a line will just go like that. What you need to do is, with your mouse, rotate that line one way or the other until it goes through another one of these. For example, 0, negative 6, it might be right here. So you kind of move the line around until it actually goes through that point. Rotate it around till it goes to that point, and then you click on submit, and you're done. That's how you graph a line. So some of these questions are going to have you first build a table, and then use your table to graph a line. To graph the line, you pick, okay, what kind of graph am I actually going to do? Am I going to do a line, or a parabola, or a circle, or a hyperbola, or something that we'll get to later? Well, you're going to pick line. Duh. Okay, these are all going to be lines. You click on the first point, one of the points, and a line will appear, but it's the wrong line. So you have to spin it, twist it with your mouse until it goes through one of the other points, 0, negative 6, or 12, 9, or whatever you have. And then you submit it and you're done. That's how you graph on MARM. It's pretty easy, but it's different. It takes some learning. Okay, now there's some trick questions. Trick graphs. (2x minus 3 equals 7. Okay. What's wrong with that equation in this chapter? What's wrong with that equation in this chapter?
There's no Y.
Good, there's no Y. That's why it's a trick graph. So let me show you what you do. First, you solve for X. So you add 3, get to X equals 10, divide, X is 5. There is no Y value. So what this is saying for your table is that X is locked in at 5. That's what that's saying. X has to be 5. It can't change like this one changes. See, when there's an X and a Y, they kind of change together. Okay, X changes, Y changes. This is saying X never changes. It's locked in at 5 and there's no Y, which means Y can be anything. Because the problem doesn't care about Y. So Y could be 0. Y could be 9. Y could be -3. It doesn't matter. That's what that's trying to do. It's a trick question. So you have to pick up on it. X is 5. X is locked in at 5, but nobody cares squat about what the Y value is. Nobody cares. So this is it. Now, if we plot those points, we graph those points, again, using the graph feature, we have 5, 0, 1, 2, 3, 4, 5, 0. Okay. We have 5, 9, which is here somewhere, or we have 5, -3, which is here somewhere. So if you use the mom graphing feature, said I'm going to graph a line, it's going to go through 5, 0, but then you rotate it up, look what picture you've made. This is a vertical line. This is the line X equals 5. Every point, all those little points on this line, the X value is 5. So somewhere on here, this might be 5, 3.1. This might be 5, 11.71. Okay, every point on this vertical line, the X value is 5 and the Y value just goes on and on and on. So that's what you have to be aware of. Most of the graphs, okay, they're slanted in some form because they have an X and a Y. They'll be slanted in some way, and you're going to build a table. But occasionally they'll try and trick you. Okay, they'll try and trick you. They'll give you an equation, but one of the variables is missing, which means the actual variable is locked in and the other variable, nobody gets squat. So you graph it and you'll get either a vertical or a horizontal line. And that's it. And I'm not taking roll tonight, and good night. See you tomorrow. Remember, we have a quiz tomorrow. Okay, and I'll try and get my stupid computer to work. So take care, guys.
How are we gonna take a roll, sir?
I'm not going to take roll tonight.
All righty. Thank
I'm
you.
not. I
Um,